Okay, so we're looking at probability part 2. So it's basically just a continuation of what we did last day. And let's get into a few examples. We're basically just going to run through some examples because it literally is not a new concept. It's just looking at some examples that have a little bit more going on than the stuff that we did the last few days. So it says if a card is drawn from a deck of cards, first of all, we talked about this yesterday. How many cards in a deck of cards? Okay, so we know that this was out of 52, that's the total. What is the probability that it is a heart? Well, for starters, how many hearts? Remember how I showed you that diagram of all the cards? So how many hearts are there in a deck of cards? 13. So then how do I give my answer for this? What's the appropriate way to put this? 13 over 52. Everybody good with that? I actually don't remember if we talked about this or if you've done this, but have you heard of or did you learn about sample space? What is sample space? Yeah, Richard? So it's like the total of all the possibilities, right? So what would be the sample space in this situation? What are all the possibilities? Those would be the ones that we're interested in, but what's the sample space out of all the possibilities? All the cards, so the 52. Does that make sense? So I just wanted to make that clarification because that vocabulary is often used in the questions, but we're not going to leave it like this. What's a better way for me to leave my answer? What else can I do with this 13 over 52? We can reduce it. So I purposely used a deck of cards because 13 is a prime number. Everybody sees that? Because only 1 and 13 go into it. But 13 does go into 52. How many times? Yeah, so we end up, if we divide this by, whoops, I was going to say 4. Divide that by 13 and divide that by 13. Do you see that 1 over 4 is a good way for us to leave our answer? Good? Off to a good start? Even given the range of where our brains are functioning at, this is reasonable? Good stuff. If 2 dice are thrown, what is the probability of rolling 2 4s? I feel like we haven't done something quite like this before. If 2 dice are thrown, okay, remember we talked about how many possibilities on one die? 6. There's 6 faces, so we're going to assume it's just a basic regular die. So if I took 2 of these, oh, look at that. I actually have another one that I put back here because it holds up my computer that I'm going to have to put back. But if we were to roll both of these at the same time, we're wanting to get 2 4s. So what is the probability of that happening? Well, first of all, what's the probability? How many 4s on a single die? Yeah, so there's only one of them. Basically, if we were to roll it, we want to get like a 1, 2, 3, 4. That's what it looks like. And we'd want another 1, 2, 3, 4. So out of 6, only one of them is a 4, right? So there's 6 possibilities that would be there, and there would be 6 possibilities that would be there. So that'd be a 1 out of 6 and a 1 out of 6. So to put this together, if I only want to get to 2 4s, I would multiply these together. So what do I actually end up getting? What are the chances that if I took 2 of these and I roll them, that I'm going to get 2 4s? Yeah, it's actually only 1 out of 36. If we logically think about that, does that kind of make sense? Those are pretty slim chances. But if you think about it, well, if I were just to take them and roll, like I could get a 2 and a 3, I could get a 1 and a 5, I could get it. So it makes sense that there's only 1 out of 36 chances, the likelihood of that happening. So far, so good? Questions? Okay. If 3 books are placed on a shelf, find the probability that the books are arranged in alphabetical order by the author's last name. Okay, we got to think about this one. This is why we're doing these together. This is where things start to get a little more complicated. So, if we're doing alphabetical and we're talking 3 authors, maybe I'm just gonna, like, we could do this however we want to, but maybe since we're talking alphabet, want to just call them ABC? Everybody good with that? Okay, like you can find your own strategy, but do you see that's, since we're talking alphabet, that's maybe a good way to do it, and then we won't get it mixed up with numbers. So let's think about all the ways that this could happen. What is the probability that the books are arranged in alphabetical order by the author's last name? So basically what we're saying is we want it to be ABC. But there's other ways that this could happen. Like maybe it's A and then I swap the other 2 and it could be ACB, which wouldn't satisfy our rule here. Does that make sense? I could even have BAC if I look at it. And then I could swap those 2 and say BCA could also happen. And then I didn't do any where I start with C. Notice what I'm doing to keep organized and to keep track of this. I started with the A's first and I did that possibility. Then I did the possibility with the B's first. So now let me do the ones with the C going first. The only possibilities would be CAB. So I'm going to underline with this. And what's the last one, the only one that's left? CBA. Everybody good with that? So because this gets so confusing, do you see that I chose a strategy to keep track of things? I thought, okay, I'm going to start with all the possibilities with the A first. There's only going to be 2 of them because if A is at the start, there's only 2 other letters I could swap. Do you see the logic behind that? Then I did the B's first because I could swap the other 2. Then I did the C's first because I can swap the other 2. So this is like an organizational tool or strategy I'm using to keep track of things. Are there any other ways I could do this? I could rearrange this. Pardon? I'm just wondering, is there? Like, did I account for all the different ways that this could be rearranged? Okay, so how many possibilities are there here? Yeah, so do you see the sample space would be out of 6? So out of 6, what is the likelihood that we put it in alphabetical order? There's only 1 out of 6. So us writing out all the alphabet, like all the letters scrambled up, is a strategy to figure out what the sample space is, how many possibilities there are. So far, so good? Questions? Okay, a card is drawn from a deck of 52 cards. What's the probability it is a face card or a diamond? I actually don't think we've done anything that has one or the other. And that has another strategy that I need to go through with you. So, first of all, tell me this. When we talk about face cards, how many face cards are there in a deck of cards? 12. Everybody remember that from yesterday? Like we went over like the kings, the queens, all that stuff we talked about and went through on that deck. So there's 12 of them. And then the other thing we need to figure out is how many diamonds are there in a deck of cards? 13. Right? There's 13 diamonds, there's 13 spades, there's 13, remember all that stuff? Okay. If it's saying or, if we want the probability of this happening, well, if I only asked for face cards, what would I say? 12 out of 52. The fact that it says or tells me that I'm going to add the probabilities of these things happening together. Let me clarify. Before, when I asked about rolling 2 4s together, like those events were happening at the same time, then we multiplied. But now we're saying we want this or we want this. When it's or, we put a plus in between. So 13 out of 52. Does that make sense so far? That's good because there's still some more. So we're good so far? This is what I mean by it gets a little bit complicated. We need to subtract out of this the possibilities that are face cards that are diamonds. Because do you see some of them can be both of these things? We could have diamonds that are face cards. How many of those could we have? 3. So we could have 3 that are diamonds and are face cards. Does that make sense to everybody? So that wouldn't satisfy what the question's asking for. I need to get rid of those out of this equation. So I need to subtract out 3 out of 52. And I'm going to put these together. You don't need the brackets, but I just want to show you that's the part where we're considering all the possibilities, but then we take away the one that would actually satisfy both of these together, which is not what we want. So, are we good so far with that? What do we get in the big brackets here if we were to add those together? 12 plus 13 out of 52. And then we want to subtract the 3. So we get 22 out of 52. Everybody good with the math and how we got that? The denominator is already the same, which is nice. We just need to worry about the top. And do we leave it as 22 out of 52, or is there something we could do with that? What can we do? Simplify it. What number goes into both of these? 2. So what do we actually end up getting when we divide by 2 at the top and bottom? 11 out of 26 would be our final answer. So you see what I mean, where it's a little more complicated. There's a little more going on there.
That was easy.
Good. So that's also the reason why I have this very long list of questions.